Hello everyone, welcome back. So we're going to start Unit 2 now, the polynomial function, starting off with the idea of factoring quadratics. Now this is a very basic Algebra 1 skill, quite honestly, or even really pre-algebra, depending upon what you do in either one of those two classes, but this is still an important skill used throughout our pre-calculus class. You'll see it used often in Units 3, Units 4, Unit 7 we'll also see it, and again we'll be using these kind of factoring skills throughout here and in calculus, so you need to make sure you understand the basics and you're careful with your factoring of quadratics. So some terminology, so we're talking about a quadratic trinomial. We have a three-term expression, variable squared, variable, and a constant. So 4x squared plus 7x plus 8 would be a quadratic trinomial. Simple quadratics will have a coefficient of 1 for the variable squared, so just be an x squared or an a squared or whatever. And the idea to factor these things, we're using a reverse FOIL method. We're looking to see what numbers multiply to be the constant in our problem and either add or subtract to be the coefficient of the variable term in the problem. Because that's what happens when you FOIL the expression. The two numbers would multiply to create the constant, and then they would multiply the x and then add or subtract to create the middle term. So we have x squared plus 13x plus 36. We're looking to see, okay, what two numbers multiply to be 36 and add to be 13? Now, if you have to list out all the factors, you would have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And the 4 and 9 would be the pair that add to be 13. If we're trying to factor f squared minus 10f plus 16, so again, we're going to know it's going to be f and f. It's still multiplying to be a 16, but now, so it's still being like a positive sign here or a negative sign, but since it's a negative 10f, they're both negative signs. All right, so whenever that constant's positive, you have the same sign in the problem. Positive middle term, they're both plus. Negative middle term, they're both minuses. So what multiplies to be a 16 will be a negative 1 and negative 16, negative 2 and negative 8, negative 4 and negative 4, negative 2 and 8 are the pair that would work out for this. And the order you write it in is not going to matter. If I said f minus 2 versus f minus 8, I have the exact same answer. Now, when it's a coefficient at the end is a negative, then the numbers will be opposite signs. They're going to technically then subtract. We show a positive and a negative. The bigger number will match the sign of the middle term. So for a right here, y squared minus 5y minus 24, the bigger term will be negative to make it a negative 5. So we would have 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. So we're seeing to make negative 5, it would be 3 and negative 8. So it's y plus 3 and y minus 8. That's our factoring pair there. Notice we're not solving any of these things, we're just simply factoring them. If we were to solve these expressions, we would set the expression equal to 0, y plus 3 equals 0, solve it, y minus 8 equals 0, solve that. But more often than not, we're going to need to be able to factor these things, not really solve them out. And then for b, so we're looking for negative 56, but the constant in the middle is a positive 1, so that tells us the bigger number is positive. So it'd be negative 1 and 56, negative 2 and 28. 3 doesn't work, negative 4 and 14. Negative 5 doesn't work, negative 6 won't work, 7 will work, negative 7 and 8. And those are only pairs where negative 7 and 8 would be the pair that actually works together. So it'll be z minus 7 and then z plus 8. All right, so that's the factoring when there's nothing in front of the squared term. It's relatively straightforward. It can get a little more interesting when there's a number in front, so something that's not 1. One such method that I'll talk about at least is the idea of what's called the AC method. This is where you multiply the a and c terms together, the coefficient of x squared and the constant, and then that's where you're trying to factor to be whole add to be the b term. Not just simply the constant anymore, now it's the product of a and c that does this. We'll then split b into those two factors and use our grouping method to then factor the final expression. So for something like this right here, we would start off by doing 3 times 4, which equals 12. And they're looking for the factors of 12. It's a positive 12, so they have to be the same sign. It's a positive 8, so they're both positive. So we look at all our factors of 12 and see which pair adds to be 8, and that would be the 2 and the 6. Now, it's not to say it's going to be plus 2 and plus 6 in the parentheses. That's what's going to split the 8x into a 6x and a 2x. Because we have to remember, I'm just going to kind of do like a little side problem over here. When we FOIL, if I have 5x minus 3 times 2x plus 7, when you FOIL that, you originally get 4 terms. So we'd have 10x squared plus 35x minus 6x minus 21, which then combine to be the three-term trinomial. So what we're doing is we're trying to reverse it, so we're trying to take the middle term and split it back into what it combined from. And that's how we got the 6 and the 2. And again, we're doing that by doing the first term 3 times the last term 4, and factors of that is how we're splitting that middle term. We then apply our grouping method, where we take a look at only the first half of the problem. 3x squared and 6x both have a 3x in common, and I would factor it out, leaving x plus 2. 2x plus 4 both have a 2 in common, a positive 2, leaving x plus 2, and we should notice that they both have the same expression, x plus 2. So we put what's in front, 3x and 2, into one factor, and then the common factor, x plus 2, and that's our answer. All right. So we take a look at our next example here. So again, there's a reason why I picked the numbers I picked on the previous one there, but just now to show how we got to our end result here. So we're going to multiply our first and last numbers together. 10 times negative 21, we get a negative 210. Now, numbers that are larger, it might be tougher to list out all your possible factors. So there's a way around that. What you can do is the graphing calculator, while it can't factor for you, it can list factors. So what you do is on the graphing calculator screen, you go to the y equals button. And if there's anything typed into there, you clear it out. And you would just type in the number you want to factor. So in this case, negative 210. And then you press divided by x. And then instead of hitting the graph button like you would for y equals 1, you hit second graph and it gives you a table. And in that table, every single integer pair is listed. That's a factor. So we would have 1 and negative 210, 2 and negative 105, 3 and negative 70. 4 doesn't go into it nicely because its factor is at negative 52.5, so they have to be integer pairs. 5 and negative 42, 6 and negative 35, 7 and negative 30, 8 and 9 are skipped, 10 and negative 21. I'll keep on scrolling down the list. 14 and negative 15 would be the last pair. And we're looking for negative 29, that's the 6 and negative 35. So again, the way we can find all those pretty quickly without having to do it by hand, you use your graphing calculator, whether it's an 83 or an 84, it doesn't really matter. You just go to y equals, the number we want to factor is negative 210, so we type in negative 210 divided by x. We then hit second graph to take a look at the table, and then we just kind of scroll through the table until we find the pair of numbers we want. Again, when splitting this up, it doesn't really matter which one goes where. I like to kind of put them where the number kind of makes the most sense. So like 35, for example, could go with 10 or 21. 6 could go with 10 or 21, so it's really not going to matter in this case. For 35, maybe it's best to put it with the 10. The 5s go there, so it's 35z, and then plus 6z minus 21. So again, we set up our grouping. We recognize that the 10z squared and 35z have a 5z in common, leaving 2z minus 7. The 6z minus 21 have a 3 in common, also leaving 2z minus 7. So it becomes 5z plus 3 and 2z minus 7 for our final factored answer. All right. The numbers are not going to get too crazy for these kind of problems here, at least for our particular class. And again, there's other ways around this method you can kind of use to kind of help you pick your factors. As we saw with 1.4, if you were to graph an equation and see where it crossed the x-axis, that's a solution. So if you were to graph this quadratic, you would see it crossing at a negative 3/5 and a positive 7/2. So you can kind of use that as you know that these are going to be factors right here. That's kind of up to you how you want to go about doing that. But that's the idea of our quadratic factoring. You need to be comfortable with this. We're going to use it a lot throughout the year. So it needs to be something that's drilled into your brain if it hasn't been drilled in already, because this is a pre-calculus class. All right, so thank you for watching. I'll see you next time. We're going to talk about a different way to work with these quadratics that's not factorable.